Greetings everyone and welcome to the last video in this 10 video series. My name is Vyom Khanna and I'm thrilled to be with you all today. I hope you learned much about IoT in the previous video through the fantastic projects showcased. In the last video, we explored a pollution sensor using the MQ135 gas sensor and the basics of a flood detection system. Now, we are nearing the end of the series. But we will still delve deep into one last project, the flood detection system, which can not only be used in riverbeds and on school premises to check the overflow of water. The project aims to help people living near flood-prone areas know about the current water level. This can also help them to alert them during heavy rains and the monsoon season. It is an IoT-based system that uses the Node MCU as the central processor. The ultrasonic sensor is connected to the processor and LED lights are used for signals. As the water level starts increasing, the LEDs start glowing one by one and an SMS is sent to mobile phones of registered contacts. A flood is a natural calamity that cannot be avoided every year. The collateral damages due to floods increase every year due to no early warning. To solve this problem, we demonstrate the idea and implementation of a flood monitoring and alerting system using Internet of Things technology. To develop a real-time solution to flood monitoring using IoT and sensor networks, we propose a flood warning system that requires attention to three primary factors: data collection via gauging, data processing, the hardware and software used, and the lack of flood warning information. Now, the flood warning systems are surprisingly inexpensive to build. The factors affecting any such system's cost is the number of site locations where sensors should be implemented. Thankfully though, our solution is fairly cheap. This system works in three parts. The first part measures the water level using an ultrasonic sensor, and the second part sends the water level information to a web page using the Ethernet shield or the ESP8266 node MCU. The third part is sending SMSs to alert residents about floods. Now that we've got a basic idea of the project's concept and the advantages it would provide, let us examine some potential components we could use to do this project. Firstly, of course, there is the Arduino Uno or any other microcontroller. You know a lot about microcontrollers, mainly the Arduino Uno, so I'll keep this explanation short. The Arduino Uno is the best board for electronics and coding. If this is your first experience tinkering with the platform, the Uno is the most robust board you can start playing with. Arduino Uno is a microcontroller board based on the AT-MEGA328P. It has 14 digital input-output pins, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. It contains everything needed to support the inbuilt microcontroller. Simply connect it to a computer with a USB cable or power it with the AC to DC adapter or battery to start. You can tinker with your Uno without worrying too much about doing something wrong. In the worst case scenario, you can replace the chip for a few dollars and start over again. The next component in our project is again one which you are familiar with, the ESP8266 node MCU. ESP8266 is a Wi-Fi SoC, meaning system on a chip, produced by Espressif Systems. It is a highly integrated chip that provides complete internet connectivity in a small package. ESP8266 can be used as an external Wi-Fi module using the standard AT command set firmware by connecting it to any microcontroller. Or it can also directly serve as a Wi-Fi enabled microcontroller by programming the firmware using the provided SDK. Basically, you can even use it as an alternative to the Arduino Uno. But in this project, we will be using them both side by side. You can use another microcontroller to interact with the ESP8266 by sending AT commands via the provided TX and RX pins. This is what we will be doing today with the Arduino Uno. Pay attention to the voltage of your single lines, as the ESP8266 only works with 3.3 volt and pins are not 5 volt tolerant. Next is a component that we have not used before, albeit a crucial one to this project. It is a digital multiplexer. The CD4051 analog multiplexers and demultiplexers are digitally controlled analog switches with low on impedance and low off leakage current. These multiplexer circuits dissipate meager quiescent power over the full VDD, VSS, and other supply voltage ranges, independent of the logic state of the control signals. The CD4051 can be used in signal gating, as an analog to digital converter, and even as a digital to analog converter. In addition, it is also used for analog and digital multiplexing, which is synonymous with its name. Our next component is the HCSR04 ultrasonic sensor. This sensor uses sonar to determine the distance to an object. It offers excellent non-contact range detection with high accuracy and stable readings in an easy-to-use package. Now, we have an SG90 mini servo motor. Servo motors, or commonly called servos, are self-contained electrical devices that rotate or push machine parts with great precision. Servos are everywhere: toys, home electronics, cars, and even airplanes. You use at least a few servos if you have a radio-controlled model car, plane, or even helicopter. In a model car or aircraft, servos move levers back and forth to control steering or adjust wing surfaces. By rotating a shaft connected to the engine throttle, a servo can even regulate the fuel of a fuel-powered car or aircraft. Servos also appear behind the scenes in devices we use every day. Electronic devices such as DVD and Blu-ray disc players use servos to extend or retract the disc trays. The simplicity of a servo is among the features that make them so reliable. The heart of a servo is a small, direct current motor, similar to what you might find in an inexpensive toy. These motors run on electricity from a battery and spin at high rotations per minute, but put out a very low torque. An arrangement of gears takes the motor's high speed and slows it down while increasing the torque. The gear design inside the servo case converts the output to a much slower rotation speed, but with more torque, meaning there is considerable force but less distance. The amount of actual work done is the same, but this arrangement makes the output just a little bit more practical. Gears in a servo motor are inexpensive and are generally made of plastic to keep it lighter and less costly. The micro servo motor SG90, which is the model that we'll be using today, is a tiny and lightweight servo motor with a high power output. This servo can rotate approximately 180 degrees, which is 90 in each direction, and works just like the standard kinds, but it's just a bit smaller. You can use any servo code, hardware, or library to control these devices. They are suitable for beginners who want to make stuff move without building a motor controller with feedback and gearbox, especially since it will fit in small places. It also comes with 3 horns, arms, and basic hardware. This project is pretty simple in principle. When the ultrasonic sensor monitors the water level, the servo motor adjusts the sensor's height in case of a change in circumstances, like a decrease or increase in the water level. The Arduino controls the servo motor, and lastly, The Node MCU transmits the sensor data to a web page. A multiplexer is also used to convert the digital data into analog so that the servo motor can understand. This is an entirely concept project, and implementing it will be much more challenging than the project description. If you decide to implement this project, I'm keeping the ideas flexible as you can do so much with this project. That is why I'm going to end my involvement by simply sharing a link in the description to the code to complete the software part of this project. Using the sample code in this description, you're free to do whatever you want and make countless additions to the hardware aspects of this project. Make sure to be creative and let your minds run. It was a pleasure being with you for this 10 video series. For now though, goodbye.